No, 3, 2, 1.
Hello and welcome today to a special Digital Futures Young event on theory of AI and creativity. Viktoria, Luisa, Barbo, and I, Gustavo, Rincon, will be facilitating the dialogue. We now introduce our selected presenters: Alexandra Carlson, University of Michigan, Ann Arbor; Weilong, Liao, and Jiaming, Chen from X-Cool; Emmanouil Vermisso, Florida Atlantic University; Gabriele Mirra from the University of Melbourne; Martin Calvino, independent artist. The current team provides Eli and our team from Strelka Institute of Media, Architecture and Design, and Michaela Pnacekova from York University, Toronto. Today we have two distinguished moderators, Matías Del Campo and Danielle Bolojan, to share their insights, observations, and thoughts on today's presentations. And now a brief introduction to Dr. Matías Del Campo. Dr. Matías Del Campo, a registered architect and designer, is an associate professor of architecture at the University of Michigan Taubman College of Architecture and Urban Planning, is also a principal at SPAN, consisting of Dr. Del Campo and Dr. Sandra Menninger as a team. A brief introduction to Danielle Bolojan is an assistant professor focusing on the application of computational design and deep learning strategies in architecture and architectural design processes. Daniel is a junior associate at Coop Himmelblau, where he has the leading role of developing custom computational tools, computational design strategies, virtual and augmented realities applications, as well as robotic fabrication processes. He is currently a PhD candidate at the University of Applied Arts Institute of Architecture, Vienna, Austria, under the supervision of Patrick Schumacher. I wanted to remind everyone about the call for papers, Digital Futures Young, Sea Level, and Climate Change. We are reaching out to our community for the submission of students and young research projects for this session, Sea Level and Climate Change. Please submit, for deadline to be submitted is the 27th of March. Today's presentation will be as follows. Viktoria will be introducing the panel today with a brief contextual summary. We will then go to each of our individual panelists for 8-minute presentations, and then we will proceed to our discussion with our distinguished moderators. Our objective here is to have a dialogue that enables new shared insights and knowledge. Before we start the Digital Futures team, I wanted to thank Viktoria. Her instincts and positive spirit inspires our research group. I also will do a brief introduction. My colleague, Viktoria, is a principal of Resonant Matter, a multidisciplinary practice focused on the intersection between natural, built, and digital environments. Viktoria is a designer and independent researcher interested in ideas surrounding the cultural and spatial effects of perception and ecology. And now, Viktoria.
Thank you, Gustavo. And yeah, Gustavo is a PhD candidate and just finished his PhD, actually. He has inspired Digital Futures with all his energy and his intellect. So thank you, Gustavo. So I wanted to kind of give a brief introduction before we start with our excellent 7 presentations that we have today. So we have a lot to go through today, but I kind of wanted to contextualize it. And this is also following the previous keynote about AI and creativity that was taking place 2 weeks ago. And we are very excited to have, you know, more contributions today by our scholars that submitted and are on this panel today. So maybe you can go to the next slide. So a brief introduction. Every act of perception is to some degree an act of creation, and every act of memory is to some degree an act of imagination. This is what Oliver Sacks writes. Our bodies and minds are engulfed in a tangled multitude of sensory information from the environment, hitting our cognitive apparatus. We are not just consuming this information. Our brains are helping us build unique stories from the fragments that enter our consciousness. Our brains create and curate the world we live in. Computational landscapes are ever expanding. Computers have grown from the status of enigmatic machines of wonder to that of companions that are curating our lived reality, our Umwelt. Being digitally connected, metaphorically and literally wired to our devices has become the unique and ubiquitous state of being. Human-made technological objects are constantly evolving and are taking on new forms. Entangled in a complex feedback loop with the environments they emerge from, they have large impacts on human lived reality. Technical objects in the digital age of machine learning are no exception. Humans have embarked on the quest for creating artificial intelligence, a quest for not only creating, but also understanding biological and more specifically, human intelligence itself. So what does it mean to be human in a creative universe? What does it mean to be human in an age of artificial intelligence? And what will the role of design and architecture be in an age of artificial intelligence? Or in the words of Gregory Bateson, and that is what I want to leave everyone with before we embark on our endeavor with 7 presentations today, what is the pattern that connects? So with no further ado, I want to hand it over to our presenters. Our first presenter will be, where is he? Anyways, so yeah, please give it up to our presenters. Gabriele, I'll give it over to you.
Yeah, thank you for the introduction. I'm just having some issues with sharing the screen for some reason.
Also, I would like to ask all the other presenters to switch off their videos while the others are presenting to kind of not overload the bandwidth, if that's possible.
Right. Thank you for the introduction, Victoria. So my name is Gabriele Mirra. I'm a PhD student at the University of Melbourne. And the title of my presentation is Expertise, Playfulness, and Analogical Reasoning, 3 Strategies to Implement AI in Architecture. So in the past 5 years, I've been working a lot with computational design and applied it to solve a variety of design problems. These include tesselation and geometric problems, structural optimization, and acoustic analysis and acoustic optimization. All these problems fall into a broad class of techniques which are applied to problem-solving applications. And in order to take advantage of computers for problem solving, designers need to formalize a design problem in terms of design objectives and variables. But there is a stage preceding problem solving, which I define problem learning. And this stage is what allows designers to define and elaborate a design idea. Problem learning is a stage which allows designers to start from an ill-defined goal and turn it into a framing strategy, and finally a design idea through the acquisition of additional knowledge about the problem. So if for problem solving, we use models of design mechanism, for problem learning, we need models of the designer cognition. So what I propose in my PhD is to develop new computational design techniques, which allows the designer to engage in the creative exploration of new design possibilities. And I'm going to do this through artificial neural networks. So I've identified 3 different problem learning mechanisms. These are expertise, playfulness, and analogy construction. Expertise involves the clustering and retrieving of information related to a single knowledge domain. Playfulness is interacting with objects with no boundaries, and analogy construction is transferring knowledge among multiple knowledge domains. So I'm going to show you now some applications which demonstrate how I've developed computational design tools to account for these 3 different problem learning mechanisms. In the first application, I've developed a dataset of 40 shells and spatial structures and trained a variational encoder to extract design features from this dataset to construct a design space. The designer can then interact with this design space and start interpolating within existing design, or also draw a sketch and ask the model to interpret it and generate a design proposition. I've implemented the training model in a CAD interface, which allows the designer to sketch on a conventional CAD software and get the results from the machine in 3D. So here we see the interface, which consists in 3 nodes. We have the CAD software, then a CAD scripting environment, which allows the flow of information between the CAD software and the machine learning platform. Here, I tested the ability of the model to interpret existing designs, and this represents 3 typical architectural problems, like joining 2 different profiles in the first case, in the second case, an L-shaped footprint, or joining 2 volumes together. And we see how the model was able to interpret these footprints by proposing alternative ways of solving these conventional problems. In the second application, I tried to understand what are the properties of a design space constructed by an AI model. So I've constructed a design space with the conventional approach by defining a parametric model, and then use samples from this design space to train a variational encoder to construct a new design space. Then I compare these 2 design spaces in an optimization procedure to test what are the solutions that can be retrieved from these 2 different design spaces. And the objectives of the optimization process were a structural analysis performed with the FEM analysis, and then 2 different architectural objectives to account for features like the opening site or the footprint shape. And on the top, you can see the solutions retrieved from the human-defined design spaces, which are extremely conservative. We don't have much variation. While on the bottom, you see the solutions retrieved from the AI-generated design spaces. And you can see that there are many variations and a lot of different topologies which could not be found in the human-defined design space. In this application, I trained the model to interpret an architectural sketch and to construct an image out of it. I've implemented the well-known pix-to-pix generative adversarial network, and I've constructed a dataset specifically for this task. Then after training, I've implemented it with a graphic interface. And you can see here that the model interactively is able to interpret a very few strokes and return progressively a very detailed and consistent picture out of it. So this allows the designer to explore different possibilities by using a very abstract form representation, which is congenial to the exploration during the creative process. So now we are moving through playfulness. And the idea behind modeling playfulness is that a kid without any expertise knowledge is able to engage in creative exploration. And it does that by intrinsic motivation. So I tried to model this approach of the kid to explore new possibilities via reinforcement learning. But before moving to this complex task, I've devised a benchmark in which the agent needs to construct 2D frames. And on the left, you see the environment with which the RL model interacts with. There is a black canvas and then an obstacle. And the model needs to construct 2D frame structures by moving the cursor in the space on the canvas. And when it completes the structure, it gets a feedback from a FEM analysis in terms of structural performance. You can see here the stages of the exploration. The agent is exposed to different obstacles. And during the convergence of the training process, you can see that it starts creating structures which are not just complete, but also optimal. And here you can see how the model can be used. On the left, you see that the model is able to instantly optimize structures for a variety of boundary conditions. What's most interesting on the right, you can see that the model can interact with the designer. So the gray part is the structure drawn by the designer. And when it interrupts, you can ask the machine to complete the structure. So a limit of this benchmark is that you can see that there is not much variation and there is not creativity in the solution generated by the model. One of the reasons that the task is really naive, that there is not enough room for the model to try to explore different solutions, because for these sides of the canvas, the solution is pretty straightforward. But another problem is that we are not modeling accurately the process of playfulness in which kids engage. For example, here on the left, you see an image of a structure that is is produced by a kid, not just by placing blocks randomly, but it follows patterns. And where these patterns come from. So Froebel understood that there is some kind of patterns that the kids are aware of, and these patterns come from the observation of nature. So you see the repetition of color pattern and also the use of symmetry. So we are moving now towards the third application, which is analogical reasoning. What I'm going to do next in my PhD is to force these models to use patterns from a dataset of natural images or fractal datasets, and to reuse them in the generation of a design proposition. And this is a matter of analogical reasoning, because we are moving from one domain, which is nature, to another one, which is that of built environment. So in the end, what I'm trying to do is to moving the first steps toward the development of AI-based CAD system, which are not focused on problem solving, but on a different stage of the design process, which is specifically focused on idea generation. So what I think is that AI should be used to support and enhance the creative potential of humans, and not to replace them. So if you want to know more about my research, please visit my website or contact me if you want to get in touch for future collaboration. Thank you.
Thank you. That was beautiful. Thank you. So we are handing it over to Alexandra.
Sorry, I was muted. Let me share my screen. And then oh, sorry, there we go. Can everyone see my slides?
Yes, perfectly, all good.
Awesome. Awesome, thank you. So my name is Alexandra Carlson, and I'm a PhD student in the robotics and computer vision departments at the University of Michigan, Ann Arbor. And I've been working with Matthias Del Campo for the last several years. And we've actually kind of, through our work, have formed this lab called Architecture and Artificial Intelligence, the Architecture and Artificial Intelligence Lab at the University of Michigan. And so today my presentation is titled Defining and really exploring artificial creative processes. There we go. So the 2 points that I'm going to kind of be focusing on today are one, how do AIs contribute to creative and novel design? And I've sort of subtitled this as human in the loop AI creativity. And so in this, initially, I would kind of like to discuss sort of the pros and cons and sort of abilities of what these perception and vision algorithms actually can do. And then finally, I'm going to be presenting some recent work that we've done about encoding abstracted concepts in 3D using neural networks. So the problem of creativity is typically always been considered a human one, and the question of whether an algorithm possesses this ability is, hotly contested. Neural networks themselves, though, can uniquely contribute to the discussion and development of creative design methods. These generative AI systems are able to ingest and learn from huge corpuses of images that can span cultural and historical dimensions that a human or humans would take a lifetime to synthesize and learn. This means that they are potentially capable of generating solutions that could combine either unique patterns within a particular cultural and historical context that a human might not detect, or that they would be able to create planned solutions that combine patterns from different contexts without the influence of human bias. Furthermore, the efficacy of neural networks to emulate and surpass the performance of biological vision systems on certain tasks make them a particularly unique computational design tool for generating novel outputs. For example, neural network architectures can achieve higher than human performance on image classification tasks, suggesting that these algorithms extract visual representations that are better for classification in comparison to the ones extracted by their human counterparts. The learned visual representations of neural networks could capture new ways of seeing and understanding aesthetics. With this in mind, we can use these learned feature sets from the networks to achieve novel representations of form for standard architectural motifs. But in this context, novelty isn't only the determining factor when it comes to creativity. And so kind of continuing in the line with Bowden's thought process, when we think of defining creativity itself, there's three things that kind of go into evaluating whether or not a process is creative. And the first type involves novel or improbable combinations of familiar ideas or combinatorial creativity. And so if we think about kind of like different ideas and ways to combine them, we can kind of think of feature spaces where there's different dimensions that define our conceptual space. And we know that these features manifest in different ways in the natural world, in our reality. And ideally, what we want then when we talk about combinatorial creativity is to find combinations of these features that don't follow the natural distribution of them. And a great example of this is style transfer, where our features in this sense are different textual elements that we can extract from the features. And neural networks themselves can extract very different and geometric, different features in terms of geometry and style and transfer them in different ways. And so we've at the Artificial and Architectural Intelligence Laboratory have used this to generate novel city maps. We've used this to create 3D textural maps in designing garden elements like boulders. And yeah, so this brings us to the second, where exploring the potential of conceptual spaces, and closely related third is making transformations that enable the generation of previously impossible thoughts. And I talked about these two together because they're somewhat interrelated in the sense that they deal with taking these feature dimensions and tweaking them or drastically altering them. And I think the neural network algorithm that really lends itself to these two types of, or I should say these two subsets of creativity are GANs. GANs themselves are able to learn features from the data set without much specification. And similarly, they're able to learn these distributions and interpolate between them very well. And so we in the lab have used these to generate novel plans that combine natural elements as well as traditional floor plan elements. And we've also used them to combine different stylistic elements of different historical styles like Baroque and modern. The issue with GANs, though, and this is really what kind of gets to the cons of using, or I should say the limitations of using neural networks for creative design, is that we can't really, they don't really extrapolate well outside of their defined dimensions. And so this is kind of where we sort of hit the limitations of neural networks, and where I would argue that AI is still, I would say, considered to be an assistant or tool as opposed to a contributor themselves. And I think, irrespective of what type of neural network that we're using, we as humans and designers still need to define the conceptual spaces. Primarily, we are the ones that generate the data sets, and we create these data sets in different ways, by choosing what visual information we want represented in them. And then also too, I think a really important point to make is that neural networks are static functions. We train them on these data sets, they learn to extract these different features that might allow for novel combinations and allow for combinatorial and exploratory creativity, but then they don't generalize well, which means that this transformational creativity is sort of still the holy grail for us. And so this is sort of defined, these limitations kind of have sort of defined how we try to apply these static function approximators to new data sets. And that's what brings me to encoding abstracted concepts in 3D. And so, I see that I'm running out of time very quickly. The general idea in this project is that we wanted to leverage a very specific type of neural network, graph convolutional neural networks, to learn a mapping from 3D space to subsets of creativity. And in this sense, we chose sensibility. We chose aesthetic, functionality, semantics, and because these all serve as very strong priors for what we define as creative processes. And so we created a novel sensibility data set where each of these models, they're split between houses and columns. They varied along style axes. They varied, my slides, I apologize, they're not advancing. They varied along functionality axes, and then they also varied along aesthetic axes. And so we then trained a graph neural network to essentially learn, sorry, my slides are going crazy. Sorry, give me 1 second. Well, sorry, I'm having some technical, there we go. So we essentially trained a graph neural network to learn a mapping between these, I have to apologize, my slides are advancing and back advancing in an unexpected and unanticipated way. Give me 1 second. I guess I can, as my slides are kind of going insane, we essentially created a graph neural network to learn, to see if we could learn a functional mapping that approximates the sensibility process of a designer. And we then, in a similar vein to Deep Dream, inverted this neural network to try to transfer the learned sensibility features to different simplified mesh models. And the results, now that my computer hopefully has stopped freaking out, these results are shown here, where we are able to, I have to apologize, this is very frustrating. The results are hopefully going to be shown right now. There we go. Where we're able to actually morph simplified input models like cubes, cylinders, and octahedrons into interesting semantic shapes that have different varying aesthetic and functional qualities. And we see that as, you know, even though these feature elements are fairly nuanced, we do see that the neural network is learning to associate specific mesh features with specific aesthetic and functional elements. And something that we went through and did as a way to kind of visualize specific features within the meshes that are contributing to these valuations is we use something called gradient-based visual saliency, which is similar to Deep Dream, where we invert the network and look at what features of the mesh are actually contributing to a high aesthetic rating or a high functionality rating. And we see that, you know, the story is not super clear because in certain meshes and certain mesh features, you know, we will see like at the bottom that certain vertices actually contribute similarly to aesthetics and style, but in other meshes that is not the case. So what we have also gone through and done as a way to kind of further understand how mesh quality and vertex relationships can contribute to aesthetic and functionality rating is we leverage some of these really nice statistical regression analyses and have demonstrated that things like mesh volume, discrete Gaussian curvature at vertices, as well as average face area actually contribute to, they're directly correlated with aesthetics and functionality, which is very interesting. And so, you know, we have through our work demonstrated that, you know, this idea of subjection, like this idea of subjective beauty, which is really important in driving creativity, can be achieved. But that, you know, kind of the future work is going to be looking at how we can kind of escape sort of the limitations of fixed data sets and see if that neural networks can actually learn from scratch. Thank you.
Thank you so much,
that was really, really interesting. And never mind, we understood everything, even though the slides were kind of jumping around. You did a great job. Thank you.
I apologize. Okay,
No
good.
problem.
I have to really apologize about the slides. I think my computer is just overwhelmed. I apologize.
No, that's all good. Thank you. And now we're moving on to the next presenter, which will be, sorry, I have to check my notes real quick. So next we have X-Cool presenting. Weilong, you're already on. And we have Chen Jiaming.
Okay. Just a second.
No problem.
Okay, I have to share the screen, but I have to leave the meeting first. Sorry.
No problem. But I'm sure we have a lot of questions for Alexandra. So this is goes out to the audience and also, you know, the other presenters. Please type the questions in the chat on YouTube and we will address them to Alexandra. And yeah, other questions from the other presenters, maybe also take a note and we'll ask them during the discussion after the presenters. So thank you.
Can I just leave a thought out there, Victoria, while we're waiting for the presentation?
Yes, sure.
Yeah, I just wanted to.
Welcome.
Should we still be using the term artificial intelligence? That's the main thing I want to ask. Whether we can think of either a different term like intelligence or another term like synthetic intelligence. I just want to leave that with you as a concept, because I think the term artificial is not terribly useful in many ways. I accept completely Alexandra's arguments about the distinction between humans and machines, but I want to throw that out there, whether the terminology is not very useful.
Yeah, I think that's a very interesting discussion, and I think we should definitely talk about that as a group after, because yeah, we see the limitations, but we also see the opportunities that are coming out of this, and there's a lot going on, and limiting ourselves with terminology can be actually very, not only challenging, but maybe even dangerous. So I want to continue with that discussion, definitely. So thank you, Neil.
Okay, I came back.
So were you able to figure out? Otherwise, we will continue with Emmanouil. Okay, that worked. Perfect.
Okay.
Awesome. Stage is yours.
Okay. Thank you. It's an honor to be here. And my name is Weilong. I'm a software engineer from X-Cool Tech. Today, I'm very happy to share with you the current research progress made by our architecture research team in X-Cool Tech. And today, our topic mainly focused on how we use AI to create representation of architecture design, especially to create master plan and site plan. So the quick talk consists of 4 parts. First, I will go through the background of this topic. Then I will talk about the problems we face and our solution. Lastly, I will give a short introduction about how we use AI to create site plans. So let's start with the first part. And architecture design is a continuous process of creation. It's heavily based on visual language. So architects have to express their ideas and proposals of each design stage by images or drawings. Since the design itself is so complicated that we cannot explain them only by words, human beings have been learning how to use drawings and images to represent architecture design since a long time ago. And as building industry grows, some drawings have become parts of the standard delivery, such as the floor plan, the master plan, site plan, section plan, and so on. Only with these standard drawings can we efficiently convey our ideas to others. So site plan is one of the standard drawing used by architects, urban planner, and engineers. It shows the condition of a given block, as well as the possibilities of arrangement of buildings, parking lots, paths, landscapes, and it also can be used as base of site analysis, transportation, and urban planning. Use site plan is convenient to convey ideas and concepts because it reflects concept and design intent of architects. So as a result, architects would possibly take a long time on drawing perfect site plan in order to represent their design properly. So site plan is important, but it's embarrassing that normally we have very limited time for drawing a site plan. Typically, when drawing a site plan, the architect has to clean up lines from CD or Rhino, choose texture and style, and plan the landscape. And the difficult part is we have to do the whole process all over again if we change the original design. And all this tedious work must be done within this short period of time. And it's not easy work. It's not an easy work, even for a senior architect. So here we have two problems. One for quick landscape planning and the other for dealing with repeated manual rendering. So the first problem is plan the landscape as quickly as possible. So we try to solve this problem by using AI. And last year, we participated in Digital Future workshop. Our topic was about master sketch. We mainly focused on letting the AI model learn how architects turn their sketch into a valid image, just like the way they did in conception design stage. User can draw whatever they want as input, and our AI model is responsible for translating the sketch into an image with some creative landscape generation. Yeah, this is, so our AI model is based on GAN, namely the generative adversary network. And the main idea of GAN is that two neural networks contact with each other. And during the training, the generator network tries to create the site plan picture as realistic as possible, while the discriminator tries to tag the picture fake or not for a set of image, which contain both fake and real images. And the game result will feed back to both discriminator and generator, and finally the generator will converge, and then the output of generator should be indistinguishable from the real site plan picture. And the concept is easy to understand, but to build a system like that, it still costs us a lot of work. As you can see, the output of our output of our AI model needs further translation. So we have tried several mechanisms to make the output useful. And here is the output. Our first trial is to design an algorithm for transforming 2D output into 3D models. As you can see in the video, we might gain a better sense of scaling from the 3D model, which means a lot for architects. And well, okay. And the second trial is to improve the quality of the output. The intuitive way to do so is to feed more data to our model, and thus we collect thousands of new site plan pictures, cut them into pieces due to the same scaling, and feed them to our model. It helps improve the texture and the color style of the output. And it's the part of the training data sets. So after the workshop, we have pushed our research further, trying to explore the limit of what GAN model can do on generating landscape by DDOing a draft. So we redesigned our model and increased the number of parameters inside by nearly 1 order of magnitude. And then we feed it with more data. And then, as you can see, our AI model began to get more sense about how to generate trees and buildings based on simple hand draft. And if we increase the training iteration, the boundary of the landscape and buildings will become more clear. So due to the previous research, we have learned the basic idea of using AI in generating master plan and site plan. And the next step is to build an application for generating site plan picture. So our research and engineer team developed a very complex system to teach our model to create site plan picture. So our system contains 3 different deep neural network for 3 different functionalities. The first neural network maps the input data, which in most cases, the CAD files, and read the files and map the data inside into latent space, and then feed the data into the second neural network. The second neural network generates the landscape while keep the buildings and the block boundary unchanged. And the third neural network is a set of style transformers, which can transform the original drawing into different styles. And finally, we send the output of the network to our render engine and get final image in several formats. So there are several advantages using our apps for site plan generation. The first was we reduced the time cost from 3 hours average to nearly 5 minutes. And you don't have to worry about changing the original design and in the last 10 minutes. Secondly, we reduced the possibility of software crashing, especially for those who have to switch between CAD, Photoshop, Illustrator, and so on. And lastly, our app can be used as a inspiration trigger when architects have no idea about how to do their design. They can use the app. And here we have our demo. And here's the demo. Okay, here's the 2D input and the 2D output. And that's it. That's all for today. Thank you for listening.
Thank you very much. That was great with the subtitles as well, so thank you. So I'm pretty sure we have a lot of questions about all of this. So again, please, if you have questions and you're watching this on YouTube, please put the questions in the chat so we can address the speakers after. So thank you. And we are moving on to Emmanouil Vermisso from Florida Atlantic University. Stage is yours. Weilong, would you mind unsharing your screen so we can share screen?
Okay.
Thank you.
Awesome. Thank
Good
you.
afternoon, everybody. So it's a pleasure to be here, and thank you for the invitation. My presentation is going to be a little bit less practical than the ones we've seen until now. My personal interest is the relationship between human cognition and machine cognition, and so currently I'm an associate professor at Florida Atlantic University, and I'm also a doctoral candidate at the University of Patras in Greece, where I'm looking at this sort of inquiry, which can help us kind of evaluate human creativity through the filter of computational creativity and vice versa, of course. Right. So, in light of the very short time frame, I will probably have to skip through some information. But the main idea here is to talk about abstract thought, as a kind of factor for cognitive development in humans, and how that becomes important for establishing conceptual domains, which can help extrapolate the way we pursue computational creativity. So in this role, we can talk about two aspects, which are reproductive and creative imagination. Right? So creativity is clearly a very complex, a very rich concept, because it's often embedded in other concepts. It has traditionally been the object of inquiry of both philosophers and scientists alike. Can't believe that genius requires both imagination and understanding, but stated that the relationship between the two is kind of fluctuating. So they can serve as a kind of primary or secondary roles, depending on whether these are used for cognition or aesthetic purposes. And I think while this is not entirely accurate, it echoes this kind of certain duality, which sets apart strict purpose-driven tasks from more open-ended ones. And this is, of course, furthermore indicative of the differentiated subroles between regions of the left and right hemisphere of the brain, the relationship between the parts to the whole, convergent versus divergent thinking, which is necessary for intelligence, and so on. And so all of the above are antithetical, but also complementary relationships. So as I already mentioned, creativity is kind of a richer concept than intelligence, because intelligence is a necessary but not sufficient condition for creativity, meaning that a certain threshold of intelligence, which typically is measured to an IQ of 120, is necessary. But beyond that, the correlation is not linear, because there are other factors which become more dominant in terms of defining creative output. One of these factors may be contextual, since this is an interesting example by a comment by Dr. Jonas Salk, who actually discovered the polio vaccine, and his particular feeling was that at least his own awareness, he was inspired to actually arrive to the solution to that particular task by while being in the town of Assisi in Italy. And of course, these can open up a kind of other kind of discussion about the role of conscious versus unconscious role of thinking within establishing a solution for a given problem, which of course goes back to Poincaré's distinction between conscious, unconscious thought, illumination, and verification, right? And what's interesting to note is that the architecture of the Salk Institute, which was later built in California, is very similar in topographically to the town of Assisi. So, what I want to do is briefly talk about some kind of the earlier foundational work which was done about cognitive development almost 100 years ago by a scientist called Alexander Luria. This kind of stresses the importance of language as a vessel which allows a transition from our sensory to our rational consciousness, right? Although several other scientists like Einstein, Galton, and Hadamard mentioned that verbalization is not always necessary for thinking, I want to stay in the importance of language, at least for the sake of this particular discussion. So around the end of the 19th century, it was wrongly assumed that all logical categories which allow complex thinking, like inference and imagination, exist by default in the child's brain from birth. But according to Professor Luria, it was the Swiss psychologist Jean Piaget who first showed that the basic processes of logical thought in the form of induction and deduction are a result of development, and that in the earlier stages of children's cognitive activity, those logical processes are replaced by less sophisticated forms of transduction, in which direct impressions play a much greater part than the as yet underdeveloped verbal and logical schemas. Piaget's work later on led to the kind of development of the field of genetic logic, which regards logical categories as a result of a complex or a more complex psychological development. So Luria went on to conduct a series of extensive surveys in rural parts of the former USSR during the end of the 1930s in order to document cognitive developmental differences between different social groups who had little or no formal education. So in this and a couple of next slides, you can see examples, transcripts from the interviews, which basically demonstrate that essentially the group among which were primarily illiterate people from remote villages had a very hard time reasoning based on anything other than their own practical experience. So Luria conducted several experiments, but the two I'm mentioning here are the one about deduction and inference, which was based on syllogisms, which is what, and you can see some of the examples of questioning here. So, for example, asking someone whether giving someone a statement about two particular facts, like cotton can grow only where it's hot and dry. In England, it's cold and damp. Can cotton grow there? I don't know. Think about it. And the subject responds, I've only been in the Kashgar country. I don't know beyond that. So I think this is kind of, on one hand, fairly obvious today, but I think on kind of within the context of the early 20th century, this is one of the important kind of foundational works that begins to kind of infer the distinctions between reconstructive imagination, which essentially depends on memory and practical experience already lived, and then creative imagination, which allows more abstract reasoning to lead to inference and hypothetical situations. In this page, we see this kind of next line of experiments, which was more targeting imagination through free questioning. And for example, the subjects were asked to propose any kind of question to the interviewer in terms of learning about new things. And it would be, they were very kind of not reluctant, because they were quite eager to actually engage in anything that was relevant to something that they had already experienced, but it was very difficult to actually imagine even what to ask. So if we look at the second transcript from the right, you can see the subject is asked, what would you like to see? Other countries, other cities, and what would you like to learn about them? And his response is that probably there are interesting cities, as you say, but I don't know what's interesting about them. They took my horse away and the road is long. I can't even imagine how I would get there. So I think it's kind of important to understand that while an interest is revealed in their own direct experience, that they have a difficulty going beyond that. So I think ultimately all the results demonstrate that the social organization and education facilitated the removal of cognition from the realm of the concrete to one where hypothetical syllogistic thinking can take place. And thereby it highlights the difference between reconstructive imagination, which allows mental processing based on prior experience through access to memory, and the more complex creative imagination, which depending on abstract reasoning. It is clear that the combination of both types of imagination is necessary for creative thinking to occur. If we take a step back, just to kind of look at, from an evolutionary perspective, the human brain expanded over time. And what happened is that the distance between the centers, between the areas where you have a certain input and a certain output grew larger. And I think that created a richer possibility for creating new associations. Furthermore, that expansion specifically allowed, of course, the frontal cortex to get larger, which is considered to be one of the primary regions of the brain for imagination. From an anatomical standpoint, it's important to understand the differentiation in the hemispheres and the asymmetry of the brain, because the left hemisphere, although it's widely acknowledged that both hemispheres, regions from both hemispheres are simultaneously activated during any kind of mental task, it is still accepted that the left hemisphere or parts of the left hemisphere are responsible for tasks which are driven by a particular purpose, whereas the right hemisphere often just reaches out, so to speak, without any preconception, and therefore entails a more heuristic nature of operation when it comes to the creative process. This also highlights, of course, the qualitative relationship of the part to the whole. That relationship is important in guiding our understanding of artificial intelligence systems. The reductionist view of AI is not very helpful in terms of, for example, understanding, what an artificial intelligence can perform by looking at the literal translation from the human set of conditions to the artificial set, because as we have learned from complexity sciences, the complex systems cannot be understood by the study of their individual parts, because there's a high level of performance which results out of the interaction of these parts. This kind of concept can be understood if we look at holistic, or also known as Gestalt perception. The right hemisphere sees the whole before whatever it is gets broken up into parts in our attempt to know it. Its holistic processing of visual form is not based on summation of parts. On the other hand, the left hemisphere sees part objects. The process is not a gradual putting together of bits of information, but an aha phenomenon, which comes all at once. The right hemisphere, with its greater integrative power, is constantly searching for patterns in things. So in this, I think, slide, we can see that that kind of differentiation between our reading, our intention, our tendency to read both the part and the whole at the same time. However, the number 4 and the letter H would be perceived before the letter E and the number 8 in the smaller scale. Furthermore, in the image of the right, one suddenly, after a few seconds, begins to kind of understand that there is this kind of mixing between the landscape and the Dalmatian dog, which are all inferring this sort of similar pattern. At the bottom, we can see that the right hemisphere clearly is able to recognize an incomplete part of the whole, but having a more holistic understanding of the structure of a particular mental image, even when the left hemisphere is inhibited. Whereas on the left diagram here, if the right hemisphere is inhibited and we leave the only activation of the left hemisphere, we cannot perceive the complete picture, but we only get a fragmentation of the mental image. The non-direct correspondence between humans and machines lies at the heart of this paradox, which was proposed by Hans Moravec in the late 80s. Moravec acknowledged that tasks which are easy for humans, like sensory motor skills, are the hardest for AI, and vice versa. Marvin Minsky also emphasized that the skills which are the least conscious of are the hardest to reverse engineer. And I think this comment is indicative of the complex nature of cognitive processes in the brain, where various brain regions complement each other. Mathematician Roger Penrose provides some insight on the role of the cerebral and cerebellar regions during the execution of a simple task. Once a task has been learned, using centers in the cerebral region, it is passed on to the cerebellar region, where the task is performed automatically, so to speak, returning to the analytical process of the learning by trying to describe the steps involved in the learning can completely obstruct one's performance, as it kind of forces us to rethink something which has already been adopted, albeit on an unconscious level. And so what's interesting is that in particular tasks where consciousness, where the time reflex is based on fragmentation of the overall process, like activities like tennis or even ping pong, which actually requires much faster reflexes, the human response would be guided by this kind of more automatic, so to speak, mode, where the brain is under cerebellar control because it has already mastered the skill of returning a particular hit by the opponent, and thereby it's almost operating on an unconscious level. This is interesting with regards to, I was thinking about the promotional video which came out a few years ago, and I'm sure some of you have seen it, from KUKA Robotics, which was trying to kind of emphasize on the speed and flexibility of the Agilus robot in this kind of hypothetical duel between the robot and the former world champion in ping pong, Timo Boll. So what's interesting is going back to the comment about the cerebellar control, to understand that perhaps who's more conscious in this kind of situation? Is it the robot, or is it the human who is almost on autopilot at this point? Moving on to this kind of broader field of computational creativity, according to DeepMind co-founder Demis Hassabis, and I think some other people mentioned this today, so I don't really want to kind of repeat myself, but just basically suffice to mention that we have those kind of three ways of understanding creativity from within an artificial intelligence context, which is interpolation, extrapolation, and invention. Interpolation is what typically neural networks are very good at, while extrapolation is an area where we are improving, and of course we're still quite far from invention. Right. So within the work that at FAU, we looked at the importance of domains, of conceptual domains, in terms of creating this kind of connectivities between conceptual spaces, right? And so we used, in this project, we used music as a kind of filter to understand how we can retrieve, let's say, three-dimensional structures which can relate back to some kind of spatial conditions. So we're using the musical structure as a generative tool to conceptualize space making. Frequency, intensity, and time were the parameters that were used to evaluate the structure of the sound. Then we used Firefly to create the visualization. And 3D point coordinates were used as an input for all to perform machine learning with the TSNE algorithm. The algorithm learned the structure of the music based on a particular genre representation and then transferred this to another musical piece and allowed us to visualize it. This is still in progress, but the intent is to exit the architectural domain and conceptualize space making in a more flexible manner, looking at qualities which would otherwise be not addressed. In hindsight, of course, because the selection of the particular musical genre here is specifically important, we understand that the knowledge of that particular conceptual domain is important if we want to reach more tangible results. And I think I'm going to get back to the domain discussion in a minute, because I think basically, according to current research results, the familiarity with a particular conceptual domain is important because it both allows the designer to engage in some pre-automatic process which has already been learned without necessarily having to go through an entire search process, but at the same time, it increases the chances for persistence in the sense that breaking a particular conceptual barrier that may be necessary to make that creative leap. And so this is another project which Daniel Bolojan and I began in 2019 as part of a workshop taught at the ICADI conference, where we're looking at domain transfer using cycle GANs and primarily extrapolating relationships or interpolating relationships between the Sagrada Familia and different and other conceptual structures like mathematical deformation or interpolation between one particular style and a different particular style. But I think the most important category was that which exited the, let's say, the known or the typical customary relationships and looked at the notion of a forest and the interpolation between the Sagrada Familia and a forest. So what's important here is that as our own kind of self-critique, and kind of situating within a broader discussion about domains, is that let's say the qualitative nature of the domain is still decided by the agent and not offered by the network. And so this, I think, still remains an important barrier in how we kind of engage with or open up the possibility for a computational creativity that goes beyond interpolation. Going back to some of the challenges in relation to this kind of conceptual domain and broader understanding of data within AI, I just wanted to kind of show a few examples from art which I feel are indicative of the differentiation between and the illustration of the extreme complexity of the way that the human mind works in relation to how a neural network understands data. In kind of situations where you have these kind of recursive structures, like in Escher's drawings. The human brain automatically can infer the different relationship of the same particular pattern in different scales, but a neural network perhaps may not be able to do so, at least in a straightforward manner or in a timely fashion, unless it has this kind of labeled, more supervised. It has to go through a more supervised process to understand that beyond a certain moment of abstraction, a particular geometry is still inferring the conceptual association to that original object, which, for example, in the last image we see is a butterfly, right? At which point does the butterfly stop being a butterfly and becomes this kind of insignificant geometry? So I want to end with a few comments on broader human creativity with regards to a process that we put together between my colleagues Daniel Bolojan and Shermin Youssef, and which was partly implemented in the Digital Futures workshop last summer. What we tried to do is essentially to establish an understanding of assessing the computational aspect of creativity, not so much by looking at the results alone, but looking at the structure of the process. And I think this is important in relation to my earlier comment about domain association, because that allows this kind of flexibility in terms of connecting and let's say chaining input and output from one particular neural network, which of course is inherently assisted by a particular human designer, and another neural network which could be assisted by a different human designer. So even though within this kind of scope of work, the supervision and curating of the data sets happened with the guidance of, the three instructors, we would like to propose a possibility where the conceptual understanding, the conceptual differentiation of the different tasks as they pertinent to each particular group of neural networks is contingent and let's say enhanced by understanding and retaining this independence among the groups. So so with regards to that relationship between AI and humans, I think it clearly illustrates a necessity for a human and machine collaboration, which can lead this kind of what we would like to call augmented design creativity, where in this kind of operative framework, the process would become of primary importance. This has been also demonstrated by a lot of other theorists, including former world chess champion Garry Kasparov, who studied various combinations of human and AI players of various skills supported by weaker and stronger processes. Conclusion being that a strong process ultimately becomes more important than a strong player, whether that is human or artificial. I know that I'm probably over time, so I'm going to stop and we can address any additional comments in the discussion session. So thank you very much.
Thank you. That was really fascinating, and I think it's really great to get that kind of context because I think it's interesting that you're mentioning kind of the difference between the process and the output or the outcome and the product. So I think it's very interesting and very important in this discussion. So I hope we can come back to that. So I was reminded of Francis Chollet, The Measure of Intelligence, his famous paper, and the interesting definition of what is intelligence. I mean, this is very important in this discussion, and I think a lot of us as designers kind of forget about the very big underlying consequences of all that we actually still trying to discover what is actually intelligence. So thank you very much. That was a really, really great contribution, and I hope we can engage and contextualize a little bit more in the discussion. So thank you. We're moving on to the next presentation by Martin or
Hello.
Martin, sorry.
Okay.
Would you like to share your work with us?
Yes.
The stage is yours. Thank you very much.
Hello, everyone. Good morning. My name is Martin Calvino. I'm speaking to you from New Jersey, United States. It's about 10 a.m. on Saturday, just to place you a little bit. My talk will be non-conventional in the sense that I have been exploring of ways in which I can communicate myself without the use of PowerPoint or Keynote software, in ways that my narrative is non-linear. So I won't be describing work slide by slide. It will be more interactive. So thank you very much to the organizers of the Digital Future Talk series. I'm very happy to be here sharing my work with you. So basically, I am a multimedia artist, which means I use several media to express myself along research interests that I have. Basically, I am interested in abstract painting, the intersection of media art with science, in particular plant genomics, machine learning, and tango culture. So this is my website, so you can visit. And this is my contact info if anyone is interested in contacting me. And I also like to collaborate a lot with people from academy. So if you find my work interesting, so please don't hesitate to write me a few lines. So today I will be discussing with you some of the work I've done with machine learning, in particularly the use of deep convolutional generative adversarial networks for the generation of abstract paintings. And but before that, I just will briefly describe what I have done in machine learning. So at the beginning, I have used recurrent neural networks for the generation of tango lyrics. I am very much interested in tango culture. So what I have been doing is training networks with about 6,000 tango lyrics, create new lyrics, which contains the grammar from the past of my home country, Uruguay and Argentina, and create electronic music in which I read aloud the generated lyrics from the algorithm and create electronic music with tango remix. I have also used recurrent neural networks to create synthetic gene sequences that resemble those found in nature. And this work has the potential to create transgenic plants with machine-made synthetic gene copies, which is very important because usually you cannot patent a gene that you that you find in nature, but you could intellectually protect gene sequence that has been artificially constructed. So my first explorations with art in the visual art and artificial intelligence has to do with image classification. So basically what I did was I was interested in classifying, using classification algorithm to see if a convolutional neural network could distinguish artworks that I did by hand, by painting and drawing, versus artworks that I did by writing computer code. So which element would the machine recognize in my image as being distinctive from art I do by hand versus art that I do by computer code? And one of the important things in this work is that I use data sets entirely from my portfolio. I don't assemble data sets from other artists' image work or pre-assembled data sets. I create my own data sets from my own paintings and drawing. So basically, this is an example of a data set of hand drawings made on acrylic on canvas or digital drawings on a Wacom tablet. And these are examples of a data set, image data set with arts created with computer code, usually the processing language, sometimes Python and sometimes Max MSP Jitter. So basically, I created an image data sets with images that are squared about 256 pixels by 256. And implemented an image classification algorithm. And I could effectively train the algorithm to recognize images that derive from artworks made by hand versus artworks that were made with computer code. So you can see the classification accuracy is very high. So here I give you 10 examples. These are images that that the classification algorithm correctly classified as being drawn by hand. Only one error classified as being made with computer code with this image. And the algorithm correctly classified all the examples that were created with computer code. So the next question that the next interesting question to address was, okay, which parts of the image are being recognized by the algorithm that could distinguish handmade versus computer-made artwork? So, and I did address that on the following work, in which I dive right into visualizing how a convolutional neural network recognizes, visualizing activation functions on a convolutional neural network. So what I did is try to understand which segment of the image the algorithm is recognizing as being to one category or the other. So after I have implemented this algorithm, I want to show you some interesting results. So these are activation maps that tells you which region of the image is being activated by a feature or feature maps. So you can see that on the left, you have images derived from artworks created by hand. And on the right, in a heat map, like red, orange, yellowish coloring is telling which part of the image the algorithm is recognizing as important for classification of this image as being done by hand. And this is the activation map. So it's interesting that the algorithm is recognizing the places in the image where I just stop the line and kind of make a point when I draw in and start the new line as being characteristic of handmade drawings. And these are the activation maps for the images created with computer code, that most of them, the algorithm recognized them at the edge of the image. You can see here the heat maps and here. So this is very clear in this image here in this very sharp end of this visual element compared to the background. So just to give you an example, so this image data set that I created contains about 3,000 images. And based on that image data set, the next step was, okay, can I generate new abstract compositions based on this image? So what I did was I used a DC-GAN algorithm from Deep Convolution and Generative Adversarial Network with the same image data set. I combined all the drawings made by hands with all the drawings made with computer code. And I train a DC algorithm that you are familiar with, right? Two networks, a generator and a discriminator. And these are the results. So I did two training runs of the DC-GAN algorithm. The first was a test case with a small data set of about 740 images. And these were the preliminary results I got. As you can see, very interesting visual compositions generated by the algorithm that somehow resembled the way I do curves in my work. You can see, for instance, this type of curves and the color combinations were very surprising between what I do at hand and what I do with computer code. So the algorithm somehow helped me to visualize color combinations that somehow were unconscious in my art practice, that now the algorithm exposes to me in a very clear way that I can take this combination of colors and textures and include them back into my artistic practice. So what I did next was exactly that. So I was inspired by the artworks created by the algorithm, and then I tried to incorporate them back into my traditional abstract painting. So I would be inspired by color arrangement, the disposition of visual elements within the image, and then I will start creating my own series of abstract drawing completely inspired on the images generated by the algorithm, but combining them in my own artistic way without losing my own artistic identity. I try to avoid just copy the design of the generated by the algorithms. And these are the results. These are the drawings I have been doing so far. I started last year, and it's a continuing, ongoing project. So you can see these two examples in black, white, and green were inspired by this artwork generated by the algorithm. So I borrowed from this composition the colors that were used and try to combine them with my own drawings and make a new artwork. So these images that you see here were generated by the DCGAN with a bigger image data set of about 3,000 images. And you can see that as I increase the number of images on the training set, the artworks become much more interesting, visually much more appealing. So what I did next, so this process of training, this process of creating my work, training the algorithm to learn from my own work, and then incorporating what the algorithm generates back into my artistic practice reminded me of a concept that I have studied during my year as scientist in evolutionary ecology that we call coevolution. Coevolution is a concept that refers when an evolutionary change in one species goes along with an evolutionary change on a related species that usually interact. So let's think about a prey and a predator. When there is an evolutionary change on a prey that increases its survival rate relative to the predator would also have an evolutionary change that will make him more effective in hunting the prey. So in this sense, is what I'm doing here. So a change in the algorithm that creates a new painting, incorporate into my artistic practice, change my art, train again the algorithm, and keep going. So I named this process, artistic process, coevolutionism, and this is the overall process by which I do it. So I have my artistic portfolio, create my image data set as input to the algorithm. The algorithm will generate its images that I call artificially AI inspired art. And then these images, I will incorporate them back into my artistic portfolio. So this is so far what I've been doing is a continuous ongoing project. Just let me show you the new drawings that I have done. So I have now a collection of about 30 drawings that are all inspired on visual elements from the generated images from the DCGAN algorithm. So these are some of the latest visual work I've been doing. So in this case, these strong yellow lines were inspired on drawings by the artificial intelligence algorithm. So just let me close it here. Finally, just to close, I would like to share with you the next. Once the machine generates this new abstract art, I've been trying to think about ways to take it out from the computer screen into the real world. And one way I did that was by combining generators by a DC gun with fashion. So this is my first result along this artistic line. So this is a trouser where it's made from cotton twill fabric, printed with one of the artworks, with a collection of artworks created by the DC gun. And this trouser has it's a very traditional trouser from my home country, used by people on the countryside, which is not that appealing. So what I did is I totally remade them for a contemporary and urban outlook by printing on the fabric the AI generated work. So this is basically what I have been willing to I'm happy to share with you. Some other works I've done along with machine learning involves the automated detection of political ideology from text. I was very interested in addressing if you could use unsupervised machine learning algorithms such as topic modeling and clustering to classify, I mean, to see if collections of articles in newspaper that were published during a presidential election in my home country, if I could use machine learning to detect political leaning or political bias of a newspaper toward one's political party or the other. Just very briefly, I will show you this work and then I will end my presentation here. So in this work, I analyzed around 530 newspaper articles from 5 different newspapers that were writing about 2 political candidates that were running for president in my home country, which is Uruguay. And I combined this with a battery of natural language processing procedures, and this is the application of machine learning in which I use clustering algorithm to distinguish newspaper articles relative to the documents of governance for each political party. And then I extracted the topics from these articles and then combine them with network graph analysis to see if each newspaper would cluster together with the documents of governance for one political party or the other. So I have shared with you this file with all the links. If you like to check them out, just do it and don't hesitate to write me on a few lines if you have any questions. Thank you so much.
Thank you, Martin. That was very interesting. I think the first presentation that was really, showing the hand-in-hand work that you do with the machine. So very fascinating. I'm pretty sure we have a lot of questions, but because of time, we want to move on to the next presentation by the current team from Stanford Institute. So provides, and Evi, if you want to get started, and Artem, of course, stage is yours.
Hi, everyone. We're the current team. I'm Professor Ng, architect and researcher based in Hong Kong, currently teaching at the Bartlett School of Architecture, UCL.
And I'm Ellie Jotiva. I'm an intermediate artist and researcher working at the intersection of art and science, and I work in between Los Angeles and Sofia.
Hi, I'm Yanzi, researcher and VFX artist from Moscow, Russia.
And I'm Artem Konevskih, data analyst and machine learning engineer based in Moscow.
So we all met in 2019 at Strelka the New Normal postgraduate research program, where we started Current, a speculative project on the future of broadcasting cinema, as well as its impacts on our ecologies, both cultural and environmental. So Current emerges from the intersection of 4 contemporary trends. That's live streaming culture, volumetric cinema, AI optimization, and personalized attention economies. The speculative film Current, which you're looking at right now, is an experiential example of what this kind of new cinema might look and feel like within a few years based on the convergence of these 4 trends.
In the process of training our machines to see and comprehend, Current anchored its data feed from Livestream for its real-time and crowdsourcing qualities. Streaming data channels from multiple sources and perspectives provide Current with a means to outsource imagination. The question of how we can facilitate an artificial creative common intelligence is at the forefront. This points to a new form of creativity, where the authorship is a participatory one, and contextualize the relationship between AI and creativity in the Creative Commons. The word creativity has a root in Latin, with a Christian implication of creation from nothing, a genesis from a larger being. It is not until the 19th century that the term embedded itself in poetry, science, and art, not anymore a mere form of repetition and propagation, but a creativity that reconciles with rules, from constructing and deconstructing, a creation from something. Today, creativity has encountered its 3rd archetypical turn in the face of AI, which can take forms of rule-based and machine learning systems. The former involves the design of models with sets of rules. The latter achieve intelligence with machines that define their own rules based on available data, transcending creativity from causation to correlations, from small to big data. Alongside the film, Current experimented firsthand with a range of rule-based and machine learning systems that are readily available to any individuals, and developed a production pipeline that provides a means for individuals to collectively reconstruct, navigate, and understand event landscapes that are often hidden from us, such as the handling of trash and changes in Nordic animal behaviors. In the process of iterative feedback, filling in voids between sensory data into an endless stream of history, where designer intuition and algorithmic generation come together as a larger whole. This is how Current define artificial creative common intelligence.
In Current, we're talking about personalized volumetric live stream cinema, which means you will navigate the 3D world composed of live streams and other types of media, forming your environment. Users can use not only 3D generated data, but all the previous heritage of video content could also be converted into this 3D space. For example, we use technologies like photogrammetry and monocular depth estimation for reconstruction of some environments in our film, just from thousands of hours of YouTube videos. So if all this comes into one place, you'll get a huge real-time simulation with its own architecture based on your preferences. These preferences could be calculated in real time according to your mood, like the new suggestion algorithm in development right now by Spotify, which makes this decision according to your voice and other inputs. Every slice of this simulation is a film on its own, carefully arranged by suggestion algorithm with the AI hand-picked moments in time and space, a seamless 3D fabric woven by AI.
The rise of convolutional neural networks made a revolution in computer vision and opened the way to very intricate algorithms like object recognition, image upscaling, and image synthesis with generative adversarial networks, or GANs. This made us think that computer finally got the ability to understand the world around us. Moreover, computer became creative, they have imagination. With the help of AI, we can generate new worlds never seen before by creating images or videos out of previously seen content. adjusted to specific scenarios, either generated or handwritten to satisfy the viewer's desires. The development of autonomous cars acquired the change of paradigm of machine vision from 2D to 3D vision for better navigation in urban environment and for more adequate understanding of what is happening around us. Thanks to this, we are now witnessing a new revolution of AI. Now it thinks in 3D. This brings us better 3D scenes reconstructions, even from one shot, faster and more realistic rendering, but also new algorithms of semantic segmentation, which bring the ability to recognize objects and their actions in volumetric space. Now guns can fantasize in 3D by generating not the images, but the objects themselves.
And our contemporary attention economy commodifies users' attention for data licensing from business to business currently, often leaving individuals, users with little to no control over the value that their attention generates and where it goes. So we're asking, like, what if we're able to interact peer-to-peer and collectively direct the value of our attention to volatile environments marked by instability and contested events, both artificial and natural? In this way, Current raises the question for socioeconomic inclusivity of non-human vantage points. For example, in the contemporary shift from centralized networking platforms to decentralization through crowdsourcing protocols, or the design of rule sets that guide our data communications, this inspired us to consider how streaming big data that reflects real-time climate change and multiple animal points of view can result in maybe landscapes that begin to own themselves. We ask, how can a decentralized network of humans, machines, and environments extend their network effects from the virtual back to the physical? These are some of the core research questions behind Currency, which is our most recent iteration of Current. In it, we propose a volumetric live stream platform that can harvest attention values and then return them to the endangered environments caused by rapid urbanization. By placing these volumetric reconstructions of volatile ecological sites within virtual events, we can foster more awareness, attention, and tangible support for them through distributed blockchain technologies. Within Currency, we also search for the role of AI in our attention economy. We ask questions like, how can machine learning assist us in directing values within distributed contexts? And can we imagine a crowdsourced coded intelligence that consistently updates itself as a universal protocol? And perhaps more importantly, how can these new synthesized networks between machine, human, and environment stimulate new imaginations and creative expressions?
Artificial intelligence increasingly molds the clay of the cinematic image, optimizing its vocabulary to project information in a more dynamic space, embedding data in visuals, and directing a new way of seeing from planar to global, flat to volumetric, personal to planetary. With these collectively reconstructed and synthesized worlds, Current will be hosting a series of virtual events to expand our modes of interaction in the volumetric space in 2021, including 3D chess play, virtual signaling fashion show, and Swire, a distance-aware real-time audio data system, a volumetric choir. The consistent effort should not be credited to Current alone, but also our international network of talents. Current always welcome anyone who wishes to collaborate. We have been very lucky in receiving many hands who have reached out to us in facilitating an artificial creative common intelligence. For opportunities participating and collaborating in our upcoming virtual events, please visit our website, www.current.camp, and our Instagram page @current.camp. Thank you so much.
Thank you. Thanks for watching.
Thank you. That's fantastic. Thank you guys so much. I mean, it's provocative, but also fascinating. I really enjoy it. Thank you. And I was actually reminded of what James Lovelock was describing in his book Novacine, where basically the agency will be given to machines to take control over planet and weather conditions, because we as humans are failing at it due to our chaos. So I thought it was really interesting that you guys are incorporating thoughts like that, which are very provocative. So I would love to hear other people's comments about this. But before we do so, Please, Michaela, take the stage as our last presenter today. Fascinating topic, and I hope we continue the discussion after.
Great, thank you. I loved the current presentation, so I'm happy that I'm presenting after them. But also that's kind of a hard job because the presentation was great. So I'll be talking about. Do you see now my screen, my presentation? Just to.
Yeah.
Yes.
Okay, great. So my computer is, sorry. So I will be, first I wanted to introduce myself. My name is Michaela Pnacekova, and and this is also, my presentation is going berserk a little bit. So I am going to, wait a moment, stop share.
And if you would remove the windows from the Zoom, there's certain areas a little bit covered from the Zoom window.
Do you mean which?
It's probably the chat or the participants that are covering it.
Great. Okay, so I have to, so I'll do the speaker view, I guess. And then you'll see only. Okay, let's try again. Now I will put, okay. Is this better?
It's taking a moment. I can't see it yet.
I think you need to unshare and then select the particular icon on your screen that you want to share.
Maybe try it again, unshare and share again.
Okay. I'll do that. Sorry. Okay. Okay, so share. Okay, now it won't find the window that I wanted it to, so that's great. Okay, I think I closed the window that this is embarrassing. But anyway, so I'll start talking about myself. So I am an XR creator and a PhD student at York University in Toronto, Canada. Originally, I come from Slovakia, and I used to be, so I'm not in computational arts. I am in actually cinema and media studies. So I will be talking about AI and human co-creation as a form of storytelling today. And I'm trying to find the window that I closed, but I will, this is like stress and, okay, here we go.
No worries. I mean, while you do that, I just wanted to say that please, everyone, get your questions ready. And I think we're excited to have the discussion. I think that it's been a wonderful morning, at least from California standards. And I think we're almost ready to go. I would actually invite, oh, I think we're there. Thank you.
Yeah, we can see it.
Now I'm going to.
Awesome.
We can see it. Now I'm trying to do the presentation mode. I think I have the same thing with the Google Slides as one of our speakers had. But I also did. I have it also in PDF, so I might do that.
Yeah. It says present from beginning, so maybe you just.
Okay.
It's going. Perfect. There we go.
Okay. So. Okay, but I need my presenter view. God, the Zoom is making me crazy. Anyway, okay, so I'll just start. Can you see something?
Yeah, we can see it now. We can see it now.
Okay. Okay. So I cannot move this. Okay, great. So I will talk about the personalized algorithmic. So I will talk about human AI interaction within my creative practice and what I called personalized algorithmic storytelling, which I paraphrase from William Uricchio, who coined the term algorithmic storytelling. How I understand it, it is that it is a software-based, AI-based storytelling and algorithmic narratives grounded in users' personalized data, which influence the content. And content becomes the form, and the software becomes the narrative, gameplay, and the plot. In order to make software and artificial intelligence visible and experiential in my work, I let the technology and agency fail. Only then we can learn the borders of the given technology and limited control of it. I do this through balancing between immersion and alienation effects, which compose the emotional scale and experiential design of each piece. I will talk first about Chomsky versus Chomsky by Sandra Rodriguez that I co-produced on a German side. Just to give you the context, I used to be a producer and creator in Germany, in Berlin, where I lived for 9 years. So that's why I was the German co-producer of this project. And it was developed together with the National Film Board of Canada, Schöne Bunte Bilder, and I Still Film. It premiered at Sundance New Frontier. I wanted to share a trailer, but maybe because of the time shortage, I won't, but you can certainly Google it. Chomsky versus Chomsky, first encounter, is the first digital portrait made of the famous thinker, let alone the one that uses his own theories of language to digitally create a Chomsky AI. His generative grammar theory gave the base to natural language processing after all. The main subject of the experience is the user, and thus Chomsky AI is a case study and a guide. We offer here, with this experience, which is a virtual reality experience, a playful and easy access into machine intelligence. And we will rely on immersive documentary storytelling. The distinctiveness is of an interactive project where one can question AI by interacting with AI. Regarding the technologies used in this project, Chomsky AI builds on 4 sets of technology currently, So it's a chatbot system with a branching Q&A services. So it's a Q&A maker, a deepfaked voice for which we use Lyrebird, an intent analysis AI system, Luisa AI, and fourth is the complex conversational machine learning AI BERT. We are also currently experimenting with GPT-3. The data library used to feed the conversation draws from 5,000 questions and 6,000 answers taken from public domain Chomsky material. And like all current conversational AI, the backend system is also highly scripted. After all, the goal of the experience is not to create a Chomsky version of Siri, but to support a compelling narrative and a fluid conversation with Chomsky AI. To do so, we created a robust system where Chomsky AI listens to users' questions and then uses an algorithm to predict the question's intent and content before deciding which of the 3 conversational AI nodes to choose from. So these 3 nodes are, first, it's a simple chit-chat bot, what most digital assistants do with static responses to generalized questions, a controlled dialogue flow following a narrative script, inspecting user responses for intents, tracking previous answers, and determining next appropriate response. And the third one is to draw from answers created by our complex conversational bot that uses natural language generation, which is BERT. The AI system finally responds by transforming text answers to speech and emulating a Chomsky-like voice deepfake. Not only do the users co-create through helping train the AI with their interaction and with their language, but through using their tone of voice, questions, and audio inputs, they co-create a unique sound environment and a musical score via an algorithmic mechanism. Which brings me to the next project that I co-created together with Jenny Baliu. It was inspired by the book, The Music by Matthew Herbert. Symphony of Noise is a sonic VR experience that uses sound and melody as a way to algorithmically create and organize the world around us. The noises of everyday world are made into algorithmic musical score through interaction in virtual reality spaces. The user creates music with sounds, object, and their body. Through interacting with environments such as movement, hand gesturing, breathing, and walking, it was our aim to create sonic landscapes that are universal, but at the same time, highly personal. The backend was done in the Unity game engine and Maximus P. It's not, I just want to make clear that it's not a per se AI experience, it's an algorithmic experience. However, I want to go a little bit deeper into the experiential design that I use in my work, which is a balancing act between immersion and alienation effects. So in Symphony of Noise, you enter space, which you see on the right side. Those are screenshots from the first from the first world, and the user blows into microphone when the bass is created, and a bubble appears, and it grows bigger by blowing into the microphone. So the immersion happens through personalization and agency of the users. So the users activate sound through controllers and through breathing. However, the alienation effect it happens when the machine takes over. So the algorithm distorts the breath into a bass wobble. In World 2, the voice activation via microphone creates melody. So the user sings and speaks into a cave ice sculpture in the space. So immersion again happens through the personalization effect and agency effect, which is basically the voice activation and singing, and the alienation effect is again voice distortion through an algorithm. There are two more spaces, and finally in the final space, the user creates together with the machine an algorithmic personalized score. I'll just briefly introduce, there are several other projects that I worked on. So one of them was Pre-Crime Calculator that we made in 2017, which was launched on iTunes. It's again an example of algorithmic, like documentary algorithmic storytelling, where we basically simulated and made our own predictive policing software to show the biases and basically the workings and functionalities of prediction policing softwares and how they used. And we based this on the interaction, personalized interaction through their of the user through their own data and facial recognition. The last piece, the piece that I'm currently working on within the Immersive Storytelling Lab, which is a part of York University, is called Home is the World. And I'm asking, I'm asking the question, what is the relationship between human and AI memory, its failure, and what happens when human and AI recreate memories together. Yeah, that's it for me. Thank you. This is my email address at your university. Yeah, I'd love to be in touch with you if you want to. Thank you.
Thank you. That was fascinating, and I can highly recommend checking out the videos, the trailer. It's really fascinating. And to transition into the discussion part, I want to invite our distinguished moderators, Daniel and Matthias, to join us for the discussion. And I'm pretty sure everyone has a lot of questions. We've seen so many projects today that really span a variety of approaches to AI, creativity, working with machines, being inspired by machines. So it's really fascinating what we've seen today. And I'm sure that everyone has questions. So please also ask each other questions. I will be addressing questions from the audience later on. But yeah, I also want to invite Neil to join because Neil would like to ask a question. So I want to give the stage to Neil.
Okay, I want to do that. Matthias and Daniel kick off first, but let me just kind of throw mine out there. You know, I just want to say that kind of from a theoretical point of view, I think the importance of theory, and what is theory? But I think theory is about asking questions, and I really think we need to kind of interrogate very precisely the kind of questions about creativity that we've received. I'm much as I respect Margaret Bowden, I think that her approach is probably much outdated. I think we need to kind of start challenging many of those things. I think also, particularly the emphasis on the product rather than the process, I find a little bit disturbing. As someone who likes to think of himself as creative, I see it more based on a creative urge than trying to analyze the kind of the production or indeed the strategies used for the production. So, you know, I think I forget the name of the first person who was speaking, but it was outlining a series of different strategies that he put together. I think experience, playfulness, and analogy construction. I don't know the basis of those things. I don't know the basis of Margaret Bowden's thinking actually on these things. I think really we're in a stage when we need to really absolutely challenge something. But there was something that I really found very intriguing. I'm always struck by the fact that Melanie Mitchell says that AI can't be creative because it doesn't have consciousness. I mean, I don't know that we're conscious of everything we're creating. And I really like the comment that Manos put out there by Roger Penrose. Perhaps consciousness is, after all, merely a spectator who experiences nothing but an action replay of the whole drama. I mean, I think we're at a stage now, and I want to thank everyone for the presentation today, of really collectively rethinking what is creativity, challenging all these assumptions in the past. I'm not sure that human beings are even aware when that kind of light bulb moment happens, when these things appear. Maybe afterwards we think, oh, that's cool, that's cool. But I think we're really in a stage where we've got to kind of challenge many of these received assumptions, because I think we're at a point where, based on what I'm seeing today, we can start to really rethink what creativity is. But I want to hand over to Daniel and Matthias, because I don't want to be these are the guys who've been invited today. So Matthias and Daniel, thank you for the presentations. Really, I was really struck by these things. Really struck by them. Fantastic.
Thank you, everyone. Yes, it was a very amazing set of presentations, and right now my network, my head is spinning like crazy, how to process the entire information, how to come up with a coherent, in a way, thought process, in a way. So I really congratulate everyone. It's really, I think, many of the presentations, they raise very interesting questions, and I think also what Neil was saying, I was also thinking about the same kind of idea when it comes to consciousness in creativity. And for me, it's is it important for consciousness to be creative, in a way? Because we are saying that networks, AI, they are not conscious, so that means they are not creative or something, which is very sketchy for myself. Yeah, it's a very sketchy, in a way, understanding, because if I'm thinking about consciousness, yes, is great as a human condition, but in the same time, it could be a very negative thing, yeah? Because if we are thinking about AI, we are talking about biases in AI, yeah? But most of the time when we are talking about biases in AI, we are referring to this kind of racial, in a way, biases or this kind of aspects. But a bias is also a human condition, yeah? Human condition is also a bias, for example, yeah? The way that you are encoding certain things, that's also a sort of bias, yeah? So for example, if I'm very conscious about the process, I'm going to encode that kind of consciousness into that network, or the way I'm training things and so on, yeah? So what that means is that, you know, for example, let's imagine a creative process. So if you start to draw something, and let's go back to drawing, and I'm saying this based on a discussion that we had with Wolf Prix, which is a great architect, like a star architect, and design principles at Cognition. And we had the discussion with him, a lecture on Tuesday, and he was mentioning this kind of idea of subconscious in the design process, yeah? So he was explaining, in a way, if you are very conscious in the design process, in the creative process, what could happen is that you're drawing something, let's say you're sketching something. And if you are very conscious about what you're sketching, suddenly you start to process and say, okay, I cannot do this because this is going to be too expensive. I cannot do it this way because it's going to be made out of concrete, let's say, or this kind of issue, structural issue is going to come up. So suddenly I cannot draw things in that way. Yeah. So consciousness in that instance then makes you be obedient. Yeah. Makes you in advance, in a way, makes you act in a certain way. And you know, a very pre-described, let's say, way, yeah? It doesn't allow you necessarily to go outside of your consciousness or outside of what you understand as being correct, yeah? And this is a very similar thing that happens also in neural networks, yeah? I think Manos was pointing to, Manos Vermisso was pointing to this three type identified by Demis Hassabis: interpolation, extrapolation, and invention. And if you are thinking about it, then if we are conscious about the design process or creative process, mostly we are interpolating. Within our what we are conscious about, yeah. But we cannot extrapolate outside of what we are aware of, yeah. So is that then the consciousness? Is that something that is actually important for the creative process? Or is something that actually just holds you back and doesn't allow you in a way to go outside, yeah? So I think this is something that probably I would also like to hear the thoughts of the presenters. Where do you see, in a way, this kind of idea of consciousness in the creative process? Is it something that actually helps us, or is it something that makes us be extremely conservative without actually realizing it, yeah? Conservative in the sense of, you know, you're really like just working within what you're aware of, yeah? You're not going outside, and you're not challenging, in a way, your own, in a way, understanding of things. And then also I would like to bring the topic in of, we are discussing about types of or creativity. And in some instances we are talking about, or some presentations talked about AI being used as a sort of almost like an inspiration, as a sort of muse. And in other cases, we are talking about the AI actually being creative, yeah? So here, if we talk about creativity as a muse, or AI as a muse, or this kind of digital tools that we are using as a muse, then for me, that will be the question, yeah, about like, are we encoding our own human condition into this kind of algorithms? We are too conscious about the process, and then we are just encoding that kind of like very conservative, in a way, understanding of things. And then the other side of, are the machines actually creative? For me, the big question that I'm questioning currently is that machine really creative if we are not addressing the aspect of overfitting? Right now, I know that we are, most of us, we are creative. We are not so maybe tech savvy, but that aspect of overfitting, it cannot go together with the claim of creativity. Yeah? We cannot really say that something is creative if it's just overfitting, if it's just memorizing a data set, for example. Yeah, because that's the classical, in a way, Chinese room problem, where just because you know to translate something based on a dictionary or based on a rule set doesn't mean that you're intelligent enough to actually speak Chinese. Yeah. So the same also here with networks, just because you're able to output some images that look creative, that doesn't make you in a way a creative network, just because you're memorizing everything and you learn based on rules in a way that. So I would like in a way to, maybe also Matthias will intervene now here, but it would be great after that to hear some thoughts from the presenters. How do you see this kind of aspects of, is really consciousness that important for creative process? Or is it something that actually it's a strong bias that limits us to be creative outside of our own, in a way, understanding of things? And then the other aspects of creativity when it comes to machines. Yeah.
Thank you, Daniel. Thanks. Great comment, actually. And now after Neil and Daniel has taken away like the most interesting points, I'm going to try to pick up the scraps and see if I can do something out of it. First of all, thanks a lot for the fantastic presentations. They were amazing, inspiring, thought-provoking. I think there's a lot to discuss here. I'm sure we don't have enough time to do like all the things that would merit actually discussion. Yeah. But maybe I would like to start with some thoughts about creativity and, you know, how creativity, and also how to basically approach trying to create a theory about creativity and AI, or maybe even just AI and architecture in general. Because I think there is, I do agree entirely with Molly Claypool here that there is no current theory on AI and architecture, or AI and creativity in general. There are bits and pieces and floating ideas out there. And one of the main questions that come up is, I mean, I have the feeling after rereading Margaret Boden, I tend to agree with Neil that some of the thoughts here might be a bit outdated considering the frame of conversation we have today. Certain parts, however, are still true, but we still have to think about it. For example, when you interrogate the philosophical framework of creativity, you get immediately pointed towards imagination and originality. Yeah, so there is a very faint discussion about creativity in philosophy, but primarily those immediately go towards what is imagination, what is originality. And that's a question really about, can an AI be, can an AI have an imagination, and B, is it original? Yeah. And one thing that is very clear here is the question also if we can actually rationalize creativity at all, right? Is it more like an emotion? Is it really a conscious process? As Neil pointed out, it might also be an unconscious process. Is it a visceral reaction to a visual stimuli that some persons have and others don't? Yeah. So there's like a ton of things here that need to be considered. And I also think that it goes along with questions that almost become esoteric. Like it's for me, the question if an AI can be creative is like a question, can AI love? Can an AI hate? Can an AI sense fear? Yeah, these are all sort of more emotional states, which I think are very hard to encode as a mathematical element that you can synthesize. Yeah, so these are very, very human questions at the end of the day. Now, in order to understand maybe a little bit better, like how do we basically discuss aspects of imagination, I would like to point out to, for example, the writings of William Blake, who basically discussed that there is a dissociation of reason and imagination. So that already points us towards the problem of capturing these in form of a mathematical algorithm that allows us to synthesize it within an AI framework. Or Friedrich Schiller, yeah, who had a similar thinking about especially the creative process, and discusses that, for example, in his letters on the aesthetics education of man. Yeah. And there's a variety of differentiations here about the idea of imagination and creativity in terms of, do you pick up on the knowledge of others, yeah, in order to build up your own imagination and creativity? Or, as for example, Francis Bacon pointed out, everything has to be done from scratch, yeah, with experiments. So there's like these two ways of going about what actually creativity can be. I think it is, for me, as creative to pick up on historic examples of the architecture discipline and mangle them into a new project, or trying to imagine them entirely from your head, which at the end of the day is not even clear how original that would be, because my argument is that architects are really good in synthesizing knowledge that they already have acquired over time, and then produce out of that some sort of novel architectural solution. There's also questions of representation. For example, a lot of the AI work we saw also today relies on representation, imagery, 2D representation of space, right? You can go along with, for example, Wittgenstein, who actually his thinking was that alle Erkenntnis ist Abbildung, so all knowledge is representation. So the building of knowledge based on representational devices. And if you think about the AI or the neural networks we're working with, they primarily work through that sort of problem, like really creating knowledge through representation. Yeah. There's many more points here, especially like about how to create a theory, like ideas. What do I do? Do I use a deductive method? Do I use an inductive method, etc.? So there's like a variety of questions here in terms of creating really a theory out of this. But there's one last point I wanted to go to. I was really happy that Michaela pointed out the problem of bias, because it was not mentioned in any other of the presentations, and I was pretty surprised about that. Yeah, that basically the idea, and this is really a criticism, that neural networks also have a tendency to have biases, like in the way how we as the coders encode them with specific databases. Yeah, and if you look into the work of AI in culture, or neural networks in culture in general, and culture for me includes painting, poetry, literature, architecture, etc., like everything you can imagine, because there is like in every one of those fields, there is already neural work happening at the moment, neural music, for example. The vast majority of those networks and results are extremely biased towards Western culture. Yeah, so they really the dominant feature within AI work currently is the Western hemisphere. And I think that needs to, the one potential that AI neural networks has is they can be extremely inclusive if the people behind it, creating those databases, allow it. Yeah, and I think we have to raise the awareness that that's an issue. It's nothing that we should gloss over. Yeah, and I mean, I'm happy about other discourses that are picking up on these notions, which might come into the AI and culture realm. Things like, for example, Ruha Benjamin's with her book Race After Technology and things like that, or ideas from the feminist technoscience that allow us to speculate about, you know, the meaning of artificial intelligence within our creative industries. And we shouldn't forget that there is something like creative industries, and that they will be part of this discussion we are having today in a larger scale in the time to come. And with that, I would like to end my entry here, because I think I would like to have discussion also with the presenters. Yeah, thank you very much for the opportunity to make a comment about this amazing body of work we saw today.
Thank you, Matthias. I actually wanted to invite to talk about the comment that he made earlier, Gabriele, if you wanted to respond to Neil, because there was a very interesting discussion already starting in the chat, and I kind of want to bring this into this discussion about pleasure. So maybe you can repeat for everyone the comment that you made in reply to Neil's comment earlier.
Yeah, sure. Neil was mentioning consciousness as something that differentiates us humans from machines. And that's the reason he said maybe for machines to not be able to engage in creative activities. And I was thinking that maybe the difference is biological, and the fact that the reason why we engage in creative activities is because we found pleasure in doing so. And pleasure is something triggered by some very low-level brain mechanisms. And I think there is some kind of genetic reasons for us to find pleasure in doing something. And that's something that we cannot encode in a machine, not yet, at least, unless we can replicate the brain somehow in a synthetic way. Yeah, that was my argument. And I mean, this thing was recognized by Nicolas Negroponte in the architecture machine, because the very first idea of the blueprint for the architecture machine was to endowing a computer with all kinds of sensors, right? So what Negroponte envisioned was a machine that could perceive the world through all different senses. And what we are doing now, we are channeling the information like just by using just visual information, and that's a very narrow view of the world. So machines cannot experience the world; they don't have any way of seeing things the way we see them. And this is another thing for machine to not be able to reason the way we do. Yeah, that's what I said.
Thank you. I think that's really interesting because Carl Friston is also talking about that in his free energy principle, that there is still a very big difference between biological and artificial systems. And it's really interesting that he is basically pointing out that movement and attention is at the core of any organism, that it basically like moves through the world and finds attention and pleasure in certain things. So we're certainly not able yet to encode that in machines, but it's interesting to think that we might be able to. And I kind of wanted to bring that back and basically ask another question. Yes, sorry, Neil, go ahead.
I just wanted to thank you, Gabriele, for that comment. I think that's a really interesting comment. Pleasure. It makes me think of Laura Mulvey's essay on visual pleasure. I'm sure there's something down there, but maybe the term that pleasure is difficult to. Maybe it could be another term like stimulation or interest. You know, and I think these ideas have never been interrogated very much. You know, I once had a discussion with Andrew Benjamin, who used to be the big philosopher at the AA a few years ago. And he said, that doesn't interest me. I said, what do you mean by interest? What do you mean? And he couldn't tell me. You know, and I think this is really a very, very provocative question. What is that, whether it's pleasure or interest or stimulation? I think you're onto the right issue. So thank you.
But here it's also, I think, just to interject a bit here, like if you say pleasure, you're mostly talking about you as a human, yeah? Like if I'm looking at the output that the network, let's say, generates, does it create pleasure or something? But that's a sort of evaluation then as a human, but you cannot evaluate the network from that kind of perspective. Is the network creative? It's not creative because I personally don't find pleasure there. It's like, you know, I don't see it as a sort of measure of creativity then, yeah? Because the same happens also with our work, yeah? Like we have a very small pool of peers that actually find our work fascinating, but the vast majority of the population of the globe, maybe they see our work as being, you know, what's that, just noise, yeah? So in that sense, I think we have to, when we judge in a way, or separate, like, are we talking about human creativity, like, or AI that helps us to be more creative or inspires creativity in us, or AI being creative, yeah? I think those are two separate things that we have to address them accordingly in a way.
Dennis, to add to that, I think my other problem about Mark is to say, who judges? You know, who judges his creativity? I mean, the fact that Van Gogh was not even recognized in his lifetime, is creativity in the eye of the beholder or in the mind of the so-called creative agent? I agree with you.
Yeah, we should be able to differentiate between the product and the process, because the product is, of course, the creativity of a product is an extrinsic property that someone assigns to a product, right? So we are talking about the process and the driving force for someone to be creative in the first place. So we are talking about motivation. So we humans generate problems because we find pleasure to solve them. That's the reason. We make new discoveries because we generate new problems. Otherwise, there would not be any reason to progress in the sciences or any other human endeavor. We do that because we find pleasure in solving problems, in discovering new things. There must be a biological reason for that, but
yeah, I think it's important.
Manos,
Gabriele,
go
I
ahead.
agree. I think it's important to kind of distinguish between pleasure as a kind of reward mechanism as opposed to pleasure as a kind of almost evolutionary kind of factor. And I think this goes back to the Baldwin effect, and which essentially describes the fact that our genetic, let's say, change over time is partly encoded, when we're born, and partly depends on the interaction with environments. I think humans tend to kind of, going back to reinforcement learning and the whole the similar concept, right? We tend to repeat those kind of actions which would tend to increase a particular kind of physiological reactions which are happening, which in this case, referring to pleasure, give us pleasure, and avoid other ones which would give fear, pain, or stress, and so on. So I think this is kind of fundamental, but also it also situates the discussion about the process of creativity as opposed to the result of creativity. And the creativity has been studied along different layers, but I think at least on within the context of my work, I think it's very important to understand the process before we get to the point of the result, because we can learn a lot from that. And I had one more comment in relation to Daniel's and Neil's earlier point about consciousness. With regards to our perception of that as a kind of more Gestalt framework, if we understand the value of the creative moment as a kind of continuous process which depends on several let's say modes of operation, which involve both conscious and unconscious thought. If we go back to Poincaré and the understanding that a lot of the conscious kind of organization of data or whatever preparation is taking place is only perhaps a small percentage of the internal procedure that goes on in our brain. The unconscious process is much larger, and the aha moment that is not really an aha moment. It's basically a manifestation of the moment where the conscious and the unconscious converge. So we're actually able to manifest that as a possible solution. Penrose has an interesting set of interesting comments about, for example, animal consciousness, which aligns with the possibility of this in humans, and the moment when you find that a chimpanzee discovers how to actually reach for a bunch of bananas which are hanging from a particular in a particular context. And the interesting thing is that the realization leaves no doubt about whether the solution to the problem that was being processed is correct. And the same thing happened with a lot of historical studies. In Poincaré himself talks about particular answers to mathematical problems which arrive after a long period of disengagement with the task at hand. And yet what he's really highlighting is that he's extremely sure about the correctness of the answer. There's no let's say questioning about whether this is a possible solution, but it's already kind of embedded that, or there's some kind of inherent recognition that this is the actual solution to a problem. And I think this is fundamental. So ultimately, we should not forget that, just kind of to conclude here, that the unconscious and the conscious can only be examined in relation to each other. If we don't have a conscious, we can't say we have an unconscious. And we could describe them as, of course, as semantic terms for us to reorganize our thoughts. But I think at the end of the day, even on a more physiological level, if we look at the cerebral and the cerebellar distinction, I think some of these ideas become more evident in the way that some tasks become embedded automatically and recreated as part of our brain, which, again, Penrose discusses further.
Yeah, that's very interesting. Martin, please.
Yes, I just wanted to make a point based on what Gabriel mentioned about why we are creative. As one possible explanation is because it gives us pleasure. I think we cannot compare human creativity to machine creativity on the basis of pleasure, because part of the biological basis of pleasure is encoded in our behavior to reproduce and mate. We don't encode reproduction and mating in machines. So let's talk, for instance, about birds. When they have to find a mate, to reproduce. They have quite elaborate and creative behaviors to attract a female. So we don't encode the pressure or the evolutionary mechanism in machine to find a partner, to mate, and to reproduce. So the machines don't have that. Perhaps if we encode that into them, more elaborate ways of creativity will emerge, right? Because the machine have to think in creative ways how it's going to attract a partner, how it's going to reproduce, how it's going to ensure that the the descendants they are going to survive. So a lot of what we do in society has to do with the behavior of reproduction and caring for our children. So when you talk about pleasure, you have to take into account that pleasure evolved as a mechanism to ensure that we want to reproduce and pass on our genes to the next generations. And machines don't have that.
Could I just chip in something? This is a great discussion. I mean, I personally believe that we need to just kind of isolate and say we're talking about human intelligence, human creativity within a bigger spectrum. I think let's not assume that we have we're in charge of everything. And I personally believe in the notion of a second Copernican revolution of not putting us at the center of things. At the same time, what I would say is that kind of it'll be invisible to us. In a way, Alan Turing makes a comment about whether machines can create poetry and things, and he said, yeah, sure they can, but maybe only other machines will be able to understand it. So in some senses, a kind of creative, and this goes back to the kind of famous move 37 that we didn't understand in that game of Go AlphaGo versus Lisa Doll. It was kind of beyond our comprehension. So in some senses only, it's kind of like we're limited by our concept of human creativity, because otherwise we won't grasp that creativity coming out of machines.
Hi, is it okay if I jump in?
Yes, please. I was gonna say, like, Eli and you had comments. I saw your faces, so please go.
Yeah. Okay. Yeah, we're both from the current team. So I guess for me, maybe the more urgent question is when we define AI as an entity, creative or not, what utility does it actually have? Like, what are the values it will actually bring to our social, economic, or planetary challenge by us sitting here talking about whether AI is creative or not? I mean, I'm so happy that Viktoria brought up Carl Fison, who is basically just working at next door in UCL. His free energy principle is so important, not only because it sort of advance on AI advancement, but because his formulation of active inference, the notion of any organized, self-organized system would be able to use an internal generative model to minimize variation of free energy on incoming sensory data basically means that any living entity has the ultimate goal to minimize internal or local entropy within the system. So this basically ties information to energy, meaning if we're able to use an internal generative model of some mechanical or social system, we will be able to understand energy transformation through information. So in that sense, if we're saying that creativity is also an act of minimizing entropy, we can actually tie social economic value in being creative for the machine, which perhaps accelerate the process. And I think that's also something that Current is asking very desperately.
Can I add, sorry, just a second. Now me first, Daniel. No, just kidding. So I have a, thanks a lot for that comment before. I think it's a really important and interesting comment, and actually ties into what I wanted to discuss, which is actually, I raised this point already at another, I think in the FIU PhD conversations we have on Sundays. At some point, I also raised the point whether there is a point actually to discuss whether an AI is creative or not. Yeah. It seems like there is, especially like in cultural theory, there is not that much conversation about creativity as such. I mentioned before that there is like discussions about originality, imagination. I've brought up myself points like authorship, agency, and things like that, which somehow are rotating around the topic of creativity. But creativity is an enormously elusive term to discuss. It's very, very vague. Yeah, it makes it very hard to pinpoint actually the discussion about it, even in humans, let alone in a machinic process that we're using. Yeah. So I'm wondering whether we're discussing actually something different here, which is rather that the users of neural networks are encoding their own creativity within a computational framework. It's not the framework itself is creative, yeah, but the way how you label a database, which kind of material you collect to get it done, which images you're selecting to put in the database, like all of that influences the final result that a neural network will produce. And I think the creative process might happen afterwards when we interpret those results. This was mentioned today several times in the conversations. Martin Calvino very specifically talked about this, for example. I think somebody else mentioned the architect in the loop. Yeah, Daniel also alluded to this a couple of times. So I think this is rather the conversation that I think is happening here, not so much whether explicitly the machine can be creative, yeah, but rather that what the result actually means within a creative framework that pertains to how we as humans interpret the resulting things. And I have to admit that I heard for the first time the term man in the loop when it came to the use in the military industry. So they basically, for example, automated drones that could do attacks. Yeah, there was a man in the loop because it was important to understand what's the ethical implications of what the AI is going to do in this case. And I'm pretty sure this is still the case today. I don't think there is like lethal strikes that are completely automated. There's still a man in the loop for the sort of ethical implications. And I think that's the role we are playing here in terms of creativity. We're like observing the results and understanding how can we use them within our own creative practice.
That's a great comment, Matthias. I think right now I will be able to attack what I wanted to say before on two levels, which is great. Just based on also your concept. So this kind of idea of utility of AI, like what's the utility of AI? So here, for example, you're saying that we are encoding perhaps our creativity in a way in this kind of networks, yeah? And that's why personally I was mentioning this kind of aspect of interpolation, extrapolation, innovation that Demis Hassabis is talking about. Because if I'm saying I'm encoding my creativity into an AI, I'm talking about that AI is going to create interpolations based on my conscious, in a way, understanding of a subject, yeah? Because that's how I am encoding things into that AI. And then also addressing the other aspect of utility of AI overall and creativity is like, okay, if I'm encoding a certain data, that's going to be what the AI is going to output. So for me, it's like, why do I use an AI then? Just to iterate? Of course, I understand there are levels of creativity when it comes to interpolation, extrapolation, and innovation. But mostly what we are talking about, then we are talking about interpolations. We are saying we are going to use AI to help us solve certain problems that we have in the world, like climate change or stuff like that. But that AI is going to look only at the solutions that we input in a way, or our understanding of the problem and understanding of what the solution might be. So it's just going to create interpolation. So for me, that's why it's important then to think about, is that AI actually creative? Is it actually going to be able to go outside of what I'm encoding in, yeah? And I'm interested then in AI mostly at the extrapolation level than interpolation level, yeah? Is it going to be able to generate something new? Because then I see the utility of it, yeah? Otherwise, what I'm doing here, I'm just really encoding like past structures and expecting in a way that I'm just going to interpolate, I'm just going to average something out, and I might find an answer. So for me, it's like also when it comes to climate change, actually, are we so sure that we as humans, we know the answer to solve that problem? So that we are so confident that if we just input ourselves enough data into an AI, the AI is going to be able to give us the proper solution for solving the climate crisis? Or is it more like, can an AI actually shed light about a different kind of solution that we never thought of? Yeah, you know.
I actually have a comment following up to that, if it's okay. But I think the idea of extrapolation versus interpolation is really important. I think currently right now, and especially with all of the computer vision algorithms, specifically with GANs and regression networks that were discussed today, they're all static. You know, they're trained. There is this idea of training time where they learn features from this closed system, this data set, this conceptual space, and then they are deployed in the world. But it's right now, you know, none of the algorithms that we've discussed actually deal with time, which I think time is really important in actually successfully tackling this problem of extrapolation. And I think that's why it's really important to keep discussions of human intelligence or human processing and machine processing separate, because human processing is all built around time. You know, we all have spiking neural networks that are composed of spiking neurons that literally encode information temporally, whereas neurons within machine learning artificial neural networks do not encode time in the same way. And so I think that when we, you know, we almost need to kind of, in this discussion of creativity, say we can define creativity in simplistic terms for simplistic models like what we're working with right now, and then kind of set a framework for maybe controlling how algorithms are designed and use time and extrapolation in the future for what we want to actually see come out of these models. I actually, there hasn't been a significant amount of work with spiking neural networks, which are computational models that are more similar to how the human brain works. But I'm hoping that as computers and GPU chips become faster and better, that we'll see more explorations into how those models can be used for different computer vision tasks.
Oh, sorry, Victoria. We don't hear you, but I guess Manos or Michaela.
Oh, sorry. Just a quick interruption. I just wanted to clarify because we are a lot of people talking. So if you could raise your hands before you speak, so that everyone has the opportunity to speak equally. So please use the raise hand button before you speak. Sorry, Manos, please.
It's just a brief comment, because I was noting earlier when Daniel was talking in relation to you know, Matthias's comment about whether it is the actual process of you know, AI that we're using as a kind of vessel to channel our own creative thinking, you know, or if the AI itself can be creative. And I think Daniel, I agree, you know, with Daniel 100% that the problem right now is that we can encode only our conscious understanding of data into a neural network. We haven't found yet a way to encode the unconscious part. And by that, maybe this sounds kind of funny the way it's worded, but what I mean by that is that the ability to extrapolate in humans relates and involves the kind of association that happens, you know, that is really not intentional on many levels. So if we go back to, I think in my last diagram, I showed the Francois Cholet diagram, which I think everybody is familiar with, which is talking about how, unlike the classical programming structure of AI, of symbolic AI, which inputs rules and data to get answers, machine learning actually requires data and answers to give us rules. So if we take this a little bit further, I think the real way to reach this kind of extrapolation, which could somehow approximate what unconscious thinking or innovation from a human standpoint could be, would depend on a network suggesting the domains that it has to work within, and not just constraining itself to work within the domains that we set it. And by domain, I'm referring to the conceptual space of, let's say, really interpolating between one kind of architectural group and another kind of architectural group, but let's say interpolate between architecture and a completely different conceptual understanding, like in the case of Daniel's work on the Sagrada Familia, you know, the forest and architecture. This was something that was encoded by the designer. But if the network could have suggested the domain, then I think this would be a step towards, you know, making that kind of extrapolation start.
Thank you. Michaela, please, you had a comment.
Thanks I would like to address Alexandra's, the spiking neural networks question. There is an app being developed in Montreal. It's focused on sound and music, but they're doing like a lot of work with spiking neural networks and, you know, art and sound. So if you are interested in that, I can glad you put in touch with them, or just a comment on the spiking neural networks. Second thing is that I would like to maybe divert the conversation a little bit less theoretically and more pragmatically, because I saw also like in the panel on its own, we went from like theory to practice, which I dramaturgically really enjoyed. And so my question, and also like regarding my practice, like I was one of the only, and possibly there was some others, maybe I missed it, but I was the only who was talking, the only one, and probably the current as well, who was talking about or thinking about their audiences and their and thinking about the users. And what I know that some of the architectural apps were also, of course, you know, it's B2B, so they were of course functional and are made for usage. But when we look at the, you know, audience and co-creation with the AI, how users can do it themselves without necessarily being able to code, like this is where I would like to kind of turn the conversation, because it's not only about like the researchers speaking to their own kind and just like, you know, the conversation is then too close, right? We need to get this conversation out. And this is why I make stuff that might seem maybe for some people here pretty basic or let's say commercial, but at the same time, it's all about how can we increase digital literacy? How can we understand, how can people understand AI and not be afraid of it? And this is why, for instance, in my work, you saw the range from Chomsky to like musical environments or sound experiences, and through pre-crime calculator, which is, you know, which discloses the bias of predictive software in a simple way. And so it's kind of, you know, going from co-creation to also, you know, bias and the datafication of basically our digital selves. And I'm just surprised that like not many people have touched upon it. So like that would be, yeah, that's my question for the panel.
Thank you. Did anyone want to reply to that?
Yeah, that's something that we discuss a lot in Current for the last 2 years, is this embodied real-time experience of the users. And I think it ties into the conversation earlier about sensory inputs, also the point that Alexandra brought up about the relationship to time, in the sense that we have sensory-based inputs into the body, like the way that all biological organisms feel versus the machine sensory inputs that are used for training the AI. But if we can track the outputs back out of the body and see the biofeedback relationship in real time, then maybe some more interesting things can happen, especially if we're able to work with biofeedback interactions within artificial systems. I think that that's a really important potential that we have there, kind of like what Michaela is doing with allowing the breadth of a user to interact with the AI outputs. Perhaps when we start actually being able to integrate real-time data, whether it's biofeedback or big data from environments to train AI in real time, maybe that's when we're going to start seeing more engaging and creative outputs. The question is how and when, maybe.
Thank you. Yeah, that's very interesting. I also wanted to bring in, because we haven't had time for any questions from the audience yet, but this is a related question from the audience. What do any of the panelists think the role of the AI is in the context of society? I see mine as a specific engine to give a perspective. Multiple engines can be called and mixed. This is a question from Austin Cabaret on YouTube. So if anyone wanted to respond to that. what is the role of AI in the context of society. I mean, it was kind of like, you know, with the audience, you guys started talking about it. So maybe Michaela, did you want to reply to that question?
Someone else has their hand raised from
previously. Did anyone want to respond to that? Yeah, provide, sorry.
Yeah, hi. Yeah, I think, sorry, my mind just blanked for one second. Yeah, I think AI wouldn't work as a standalone system. It has to be an open system that bridge with other types of technologies, including decentralization that we see from blockchain, including the architecture machine that someone also mentioned earlier, with other types of algorithmic from procedural to rule-based system. So it's important the question of how we actually bridge between these different technology systems so that they actually act as an architecture machine that is able to reproduce itself and prolong its sustainability and be able to evolve through time. So like through different eras, we would be needing different types of AI. But if they're not open systems, if proprietary efforts and open source efforts cannot integrate into combinatorial pipeline, then the algorithm would just die. Like for instance, Alexandra and Michaela was mentioning spike neural network. If convolution and deep learning, they're not evolving and breaching into other technology systems, then spike is gonna come up and it's gonna replace them. And then we're gonna have other supercomputers, and then we're gonna have like quantum computing with exponential faster way to like decode stuff and encrypt stuff. So I think it's a means of how to actually aggregate effort between different open source and, you know, even like enterprise grade engineering.
Thank you. And since we're really, you know, reaching kind of a limited time here, it's very late in Australia now. I just wanted to give the opportunity to give last comments. It's been an amazing discussion. Thank you, everyone, to all the great contributions that you've made. Are there any last comments or questions that weren't answered? Now's the time.
Yeah. Neil has his hand up.
Yes.
I just wanted to, I think it's been a great discussion. I think we should transcribe this and do something with it because it's been really interesting. I think we're seeing things happening in a kind of, almost like a brain at work. And that's what I want to kind of just throw in there. I think some of the comments, especially I enjoyed the comments by Gabriele's comments about the kind of pleasure and all these things. But so feedback is absolutely kind of crucial to all this. But there's also feedback out of the context. And I think one of the real advantages of having a platform like this, where you can bring people together from Melbourne and God knows where, you know, is that you actually get this possibility of a real-time feedback going on. And when it comes down to it, I kind of get the sense that maybe whatever creativity is, and it is a really difficult problem, right? It might have something to do with that kind of interaction. I mean, that goes on in any sort of interaction itself. So it's kind of like an emergent phenomenon. I know that we discussed this in Manos, but I just think that we are seeing now today creativity actually happening.
I just, before we end today, I wanted to get final thoughts from Daniel and Matthias, our distinguished moderators.
Matthias, you can go ahead.
I was waiting for you to talk. Okay. Yes, so all of you are leaving me behind with a lot of buzzing in my head, like in terms of, you know, understanding, digesting, processing all that I've seen today and the conversation we had, which I agree with Neil was wonderful. And it would be great to have a transcript at some point, maybe. It is hard to summarize all that was seen today. I think there's so many different voices here. And I think this is one of the wonderful things about the development we're currently seeing in this area is that it's definitely not a form of style. It's really more like a paradigmatic shift in cultural production at all, in general. Yeah. You might have heard the term neural music and neural art. Yeah, like neural art are people like Mario Klingemann, Sofia Crespo, and many others. neural music with data bots and Holly Herndon. Who else comes to mind? Yacht, yeah. So it seems like there's a real cultural phenomenon happening. It's not necessarily a technological phenomenon in itself, right? Because that we are sitting here and discussing, is the system creative or are we as humans creative? It already shows that we're getting provoked by this new technology, and that provocation is a healthy thing to have in a conversation about a novel paradigm of cultural production at large. And I'm happy that we're seeing this also in architecture, and it's really changing ways of how we have traditionally been thinking about designing and the design paradigm in general. And I see that also, of course, in cultural production. And we saw that today in several examples. And I'm happy that this conversation was not exclusively about architecture, but it was a very inclusive conversation about a variety of different cultural areas. So all in all, this is basically, as I'm saying, you're leaving me behind with a wonderfully bossy, drunken head now to continue thinking about this. So thanks a lot for these provocations, guys.
Daniel?
Yes, thank you everyone for a very stimulating session. Like I also started my comments early on, like, you know, my network, it's kind of spinning right now. I'm trying to figure things out, and so many great ideas here. I just wanted to address briefly on a last comment that was made about the need to integrate AI with other technologies. And I think that's a very crucial thing, and probably that's why I personally have a sort of position that I have when it comes to AI, and this kind of being critical in the aspect of AI is just interpolating and just outputting whatever data we put in. And just to point to a comment that Memo Acton made like a few sessions ago in a DDES program, he was pointing to the fact that we have to understand that the neural networks that we work with today, they are mostly based on surveillance technology, or they started probably to be developed that way. And that's why also, like Matthias was suggesting at one point, you know, you have the Western, in a way, civilization, let's say, that it's very well represented in these kind of models, and less other civilizations, because mostly it's always you deal with this kind of issue of, if a civilization, let's say, has a way to document itself more, or has the technology, then suddenly that civilization will be overrepresented in a way, yeah. And I think that's a sort of problem of how we are, what networks we are using, and how those networks learn, yeah. Right now, they are just these kind of massive collectors of data. But yeah, as we also discussed in the previous discussions, like learning, it's quite different in humans than in machines, yeah. So I think this kind of, I just wanted to pick on that idea, and this kind of idea of we have to look at this technology not only in isolation, but also how it's going to integrate with other technologies, and also what other developments can be done here. And personally, I think if we can move away from networks that needs millions of data points, the better, because I think it's easier then also to remove this kind of issues of bias and so on, yeah. So once again, I think it was an amazing conversation. I wished, in a way, and this is maybe something that Digital Futures can think of, like, I wish to have this kind of discussions go on for longer, because there are so many interesting people here, and we just managed to address, I think, a few of the presenters. So that would be something amazing if we can think of a way to open up, in a way, the discussion, to have the discussion way more longer than we have it now. But thank you, everyone. Once again, it was an amazing session.
Yes, thank you, everyone. Neil, you have the stage. You wanted to say something. Neil, you muted.
Yeah, just to say, in terms of continuing the discussion, alongside the Digital Future things, we've got a doctoral platform where we're discussing things. I don't know if I can see this properly now, but tomorrow we've got a session, same time, where we have Wolf Pricks and Tom Main, famous architectural practitioners, for those who don't know, talking about how they're implementing AI in the office. And especially, we're also involving Daniel Bolojan, who's going to be talking about this amazing deep Himmelblau project that is emerging. And this is something, what we're trying to do is establish a kind of a global classroom, as it were, where everyone from all over the world can kind of feed into this. And so the discussion does continue. So I just want to thank people today. This is, I mean, when we established this thing, we had no idea that it was going to lead to this, but I really think we're getting creative thinking coming out of it, and it was a fantastic session. We're going to look at how we're going to go and publish the transcripts and so on. And I want to thank especially the guy from XCool, who showed us that we could, in real time, be having transcripts, and of course we should have these in Chinese as well. Why not? So thank you, and thank you, Victoria, and thank you, Gustavo, for all the energy put into it. Thank you also to the background team who are supporting us a lot below the surface, and thank you also to our special guest today. Amazing, absolutely amazing, fantastic. Thank you.
Yes, thank you, everyone, and take
Thank
care.
you, everyone.
Thank you.
Thank you, everyone.
Thank you, everyone.
Yes,
Thank you for the invitation. Thanks.
Thank you.
Thanks, everyone.
Thank
Stay
you.
connected.
Yes,
Bye.
stay connected. This is just the beginning. Hopefully there will be more connections. Thank you,
Maybe we'll
guys.
chat on Clubhouse.
Awesome.